Good morning. So in this video I am going to discuss a simple trick to draw Lewis electron dot formula. So here we have to follow some steps. So let us see directly with an example. Drawing Lewis electron dot formula for nitric acid, formula HNO3. The first step, we have to draw skeletal structure of the molecule. We have to draw skeletal structure of the molecule. Here the least electronegative element is supposed to be considered as central atom. So here the nitrogen is the least electronegative, that is considered as central atom, and it is surrounded by the other atoms equally. So nitrogen is surrounded by 3 oxygen and hydrogen. Okay, right. Then after that, step 2, we have to calculate total number of valence electrons of all the atoms together. Here in this molecule there is one hydrogen atom, valence electron is 1, nitrogen atom also about 1, valence electron 5, but there are 3 oxygen atoms. 3 into valence electron 6, 18, but total number of valence electron is about 24. Right, so after calculating the total valence electron, so we have to draw single bond between the atoms. Okay, so now I have drawn the single bonds between the atoms nitrogen, oxygen and oxygen, hydrogen. Right, for drawing these 4 single bonds, 4 bond pairs, 4 pair of electrons are used, which are called as bond pairs, isn't it? That is 4 into 2, totally 8 electrons are used for making these 4 bonds. Whereas this molecule has totally 24 valence electrons. So after completing these single bonds, the remaining electron will be about 24 minus 8, 16 electrons. So remaining 16 electrons are there. The remaining 16 electrons we have to distribute as a lone pair. We have to distribute as lone pair, starting with most electronegative element. Okay. Here the most electronegative element, the terminal element, is nothing but oxygen, so that the extra 16 electrons has to be distributed over the oxygen atoms first as lone pair. Okay. Now here the terminal oxygen, it has only one bond pair, so 3 more lone pairs. This also has one bond pair, 3 more lone pair. Then this oxygen, it has 2 bonds on either side, isn't it? It has 1 bond on either side, totally 2 bonds. So 2 bond pairs are there, remaining 2 lone pairs. Now all the 16 electrons are distributed over oxygen atoms as lone pair. Correct. Now we have to check whether octet configuration is fulfilled for all the atoms. Okay, so now when you look at the oxygen atom, all the oxygen atoms are surrounded by 8 electrons, but look at nitrogen, it is surrounded only by 3 bonds, isn't it? Which means it is surrounded only by 6 electrons, so that oxygen atom is 1 pair short. Nitrogen atom is 1 pair short of octet, isn't it? But now what you have to do is, you have to move the 1 lone pair from terminal oxygen to form another bond with nitrogen. Okay, now both these oxygen atoms are equivalent, so that we can move a lone pair of electron from any one of these oxygen between nitrogen and oxygen. Okay, right, now that forms a new bond now. So this is nothing but the electron dot formula of nitric acid. Now you can see that all the atoms are surrounded by 8 electrons except hydrogen, which has only doublet configuration. Okay, right. The next example is nothing but sulfur trioxide, formula SO3. Here the total number of valence electrons, sulfur 6, oxygen 3 into 6, 18, 24. Okay. Right. The least electronegative element here, sulfur, which is considered as a central atom, equally surrounded by 3 oxygen atoms. Okay, right. Now I draw a single bond between them, so that for making these 3 single bonds, 3 bond pairs, that is 3 into 2, 6 electrons are used. So therefore the remaining electrons, 24 minus 6, 18 electrons. Now these 18 electrons we have to distribute as a lone pair over the electronegative terminal oxygen, more electronegative terminal oxygen, so that 18 electrons, 9 pairs, isn't it? Over each oxygen I draw 3 pair of electrons. Okay, so each oxygen I draw 3 lone pairs. Okay, right. But now you can see that all the oxygens are getting octet configuration. One bond pair with 3 lone pairs, totally 8 electrons are surrounding each oxygen. But look at sulfur alone. Sulfur is surrounded only by 6 electrons, because around sulfur there is 3 single bonds, isn't it? So that sulfur is short of one pair of electron, isn't it? So as usual, according to the rule, we can move any one of the lone pairs of terminal oxygen between oxygen and sulfur. So all the 3 oxygens are similar, so that I am going to move this lone pair between sulfur and oxygen, which forms a new bond. So finally I am going to get this structure. Okay, this is the electron dot formula of sulfur trioxide. Okay, right. So the next example, nitrate ion, NO3 minus ion. What is it? NO3 minus ion. First I calculate total number of valence electrons. One hydrogen atom 5 electrons, oxygen atoms 3 into 6 18, 23 electrons. But this is an anion with unit negative charge. So with that electrons, I am supposed to add number of electron equal to charge per unit negative charge. So I am going to add 1 with the 23. So totally 24 electrons. Okay, right. So here the least electronegative element is nitrogen, considered central atom, surrounded by 3 oxygen equally, isn't it? Then I draw single bond between them. Around nitrogen there are 3 bonds. So 3 bond pairs are used. 3 into 2, 6 electrons are used for making this single bond. Okay, right. Total electrons 24 minus 6 18. So there are 18 remaining electrons. Okay, now this 18 electrons we have to distribute as a lone pair. 18 electrons is nothing but 9 pairs, isn't it? So over each oxygen I am going to distribute 3 lone pairs. Okay, right. So finally I check the octet configuration. All the 3 oxygens are fulfilling the octet configuration, because each oxygen has 3 lone pairs and 1 bond pair. 8 electrons are surrounding each oxygen, but nitrogen is surrounded by 3 single bonds, which means it has only 6 electrons. It's short of 1 pair. So that as usual, according to the rule, I move 1 lone pair of terminal oxygen between oxygen and nitrogen. Okay, actually I move the lone pair from the left side oxygen, so it forms a new bond. So finally I am getting this structure. Okay, plus in the formula that nitrate ion is having unit negative charge, isn't it? So I give that unit negative charge as a whole charge of this species. Okay, so this is the electron dot formula of nitrate ion. Okay, I hope you are able to follow how to draw the Lewis electron dot formula for different species. Right. Thank you, and keep watching my videos.